non-metals, and electrons, and then we have other compounds. The other types of compounds are molecular compounds that we'll be taking a look at are binary compounds. Binary meaning that they are made up of two elements. We're not the only. And more precisely, two non-metals. In the case for these non-metals, then we have a sharing of electrons as opposed to a transfer of electrons. So that the atoms that are sharing those electrons that are being shared are used to be able to fill the shells, but they're being used for both atoms. So for example, here in CO2, carbon is a 1s2, 2s2, 2s6, excuse me, 2p2. Oxygen 1s2, 2s2, 2p4. So carbon is missing 4 electrons to get to A. Oxygen is missing 2 electrons to get to A. So when we draw the structures on the valence chart, we have carbon with only 2 electrons. Each oxygen has 4. So it's 2 to be 4 for oxygen for each of the 2 oxygens of CO2, and 2s2 to be 2 for each of the carbons. So this oxygen is missing 2. This oxygen is missing 2, and carbon is missing 2. So these 2 right here then end up being shared with 2 of these. So we'll move that there, we'll move that there, we'll bring that over here, and we'll bring that over there. So now this oxygen is here. Well, carbon is still missing electrons. We can also access the s electrons. All of these are valence shells. Okay. So in the setup, then this oxygen will be the same. It will donate 2 electrons, and then carbon will donate 2 more. So from that sharing of electrons, this oxygen now has 8, 2, 4, 6. 8. Carbon has 2, 4, 8. And the other oxygen has 2, 4, 6. Everybody has an octet, but it can only happen from that sharing. So the electrons here belong to both oxygen and carbon. Those electrons there belong to oxygen and carbon. So in ionic compounds, we have ionic bonds, and covalent compounds, we have covalent bonds. Now, in the naming of covalent compounds, the name is a lot easier because all we have to do is use prefixes. And that prefix lets us know how many atoms of each element we have. So, atoms of 2 or more non-metals. Okay, share electrons. We're only concentrating on the binary ones. Okay, so there's a lot of compounds that will contain more than 2. But we're only going to look at the binary ones. And so the unit, when those electrons are shared, we call that a molecule. Now, when you're given the formula will already be in the correct order. Whatever non-metal comes first, then that's the non-metal that you name first. Whatever non-metal is second, that's the non-metal that you name second. And if you're given the name, well, the name of that comes at the beginning, that's the symbol that you put first in the formula. The name of the second part, then that's the name that you put at the end. Basically, you can ignore this part right here. Doesn't matter which one's first or second, because you will be given the name of the formula and that has an order. But when naming covalent compounds, just like ionic, there's two parts. So we have named the metal, named the non-metal, and NID, well, same thing here, but now we're going to name a non-metal. The second non-metal, but change the ending to IDE. And then add a prefix that tells us what the subscript is. And that's it. There is no charges, there's no balancing. You do not have to make sure that things cancel out. The prefix mono is only used for oxygen. And for all the other elements, if there is no prefix, then it's implied. But there is only one element. So if you have a subscript 2, you use the prefix di. If your subscript is 3, you use the subscript tri, and then tetra, penta, hexahedra, so on and so forth. There is an English rule, okay, where you cannot have A before O. So for oxide, for oxygen, you're supposed to drop the A. A lot of times, so you will notice that is not the case, but in terms of following proper English grammar, if there's an A before O, then you take out the A. Because you look at some of these names online, you may see that sometimes. But that's all it is, just prefixes. Okay, just prefixes. So CO2, carbon oxide. How many oxygens? 2. Have the prefix for 2, which is di, carbon dioxide. CO, 1 of each. So we add the prefix mono for oxygen. And remember, mono, we only use it for oxygen. If there is no prefix, then it means 1 of that element. If there is no prefix, then it implies 1. So there's no prefix here. So that means we have 1 carbon. There's no prefix here. That means we have 1 nitrogen. Di means 2, 2 oxygens. Mono means 1, 1 oxygen. Mono means 1 oxygen. And once again, mono, we only use it for oxygen. And we do drop one of the O's, so it's not very low. CS2, carbon disulfide, 2 sulfur, CO2, 2 oxygens, dioxide, and O, nitrogen monoxide, or nitrogen oxide, and 2 nitrogens. So the prefix di before the nitrogen. Now, just like ionic compounds, the second part, the second non-metal, it always ends in IDE. But only the second one, not the first one. Okay, so all of these you'll notice end in IDE. Okay, SO2, sulfur dioxide. SO3, prefix for 3 is tri, it's trioxide. SF6, 6 fluorines, use the prefix hexa, sulfur hexafluoride. That's it. Do not try to balance. You do not have to worry about charges. There are no charges. Electrons are not being gained or lost. They're not being transferred. So there's no positives, no negatives. You do not have to worry about things adding up to 0. If there's a prefix in the name that tells you the subscript. If you have a subscript, then put the prefix that means that subscript. NCO3, the name for N is nitrogen. second nonmetal, we change the ending to IDE, so chlorine becomes chloride, nitrogen chloride. We have 3 Cls, so we add the prefix for 3, which is tri. So nitrogen trichloride. That's it. So on the bottom, nitrogen trichloride. That's it, that's it, that's it. These are the, supposed to be the easy ones. Prefix tells us the whole story. And there was always, always, always 2 nonmetals. B2O3. Look at B on the periodic table, and it's called boron.
Should be diboron trioxide.
Yes. So boron oxide, how many borons? 2. How many oxygens? 3. So just diboron trioxide.
Does capitalization matter?
No.
Okay.
They're names, but they're not considered to be
The element.
proper names like these. That's it. That's it. That's it. No problem. Working backwards, they're the same thing. So we got phosphorus and oxygen, diphosphorus pentoxide. Phosphorus is phosphorus, oxide means oxygen,
So it's P2 and
di means 2,
5.
pen means 5.
Okay.
P2O5. Again, that's it. So, 2 different types of compounds. The very first thing that you need to look at is the beginning of the formula or the beginning of the name. If it begins with a metal or ammonium, it's ionic, and we follow the rules for ionic compounds. If it begins with a nonmetal, okay, then we check to make sure that there's only 2 nonmetals. Then it's a covalent, i.e. molecular compound. So K2O. K is a metal, so it's ionic. Name the metal, name the nonmetal, or name the negative ion. If it's a nonmetal, make sure it's an IDE. If it's a group, look it up on the handout and write whatever the handout tells you the name is. So K is potassium, O is oxygen, oxygen becomes oxide, potassium oxide. Okay, do we need a Roman numeral? Potassium oxide. No, because potassium is a group 1. Group 1, group 2, group 3, zinc, cadmium, and silver do not need Roman numerals. So that's it, potassium oxide. On the bottom, N2O, nitrogen's a nonmetal, so we use prefixes. How many nitrogens? 2. That's a prefix for 2, dinitrogen. O is oxygen, oxygen becomes oxide. We only have 1, dinitrogen oxide or dinitrogen monoxide. Oxide or monoxide, both are valid. Always look at the very first part. If it begins with a metal or ammonia, follow the ionic rules. If it begins with a non-metal, follow the covalent. prefixes. Prefixes, make sure everyone's an ID.
The first word is metal. Sorry.
It is ionic, and you have also two parts, your positive port and your negative port. If it's a monatomic ion, that means it's a nonmetal. All your monatomic ions are nonmetals and they end in IDE. If it's polyatomic, see the chart. The chart tells you the name, the charts, and the formula. The chart provides us with all the information. Almost all of them end in 8 or 8. Except for those 5. Azide, hydroxide, cyanide, peroxide, and thiocyanide. All the other ones end in 8 or 8. On the positive side, if it forms only one positive ion, you do not need a Roman numeral. If it can form more than one, you need a Roman numeral. Okay. The ones that only form one, group 1, 2, 3, zinc, cadmium, and so on. Group 1's plus 1, group 2's plus 2, group 3's plus 3. Zinc, cadmium, memorize that is plus 2, silver plus 1. Questions? SI, silicon, metal or non-metal? There's a
No.
periodic table over there,
Oh,
and you need to use it. Silicon's atomic number 14.
not metal.
It's a non-metal. So when using non-metals, use prefixes. How many silicons? So it says silicon. We don't need to add more. Chlorine becomes chloride. How many? What's the prefix for chlorine?
Tetra.
So silicon tetrachloride. That's it. P2O5. Phosphorus, metal or non-metal?
Non.
How many phosphorus?
Diphosphorus.
2 phosphorus. How many oxygens?
5. Penta.
And notice that we dropped the 8. So diphosphorus is toxic. Cl2. How many chlorines?
2.
Dichlorine. Prefix for 7 is hepta.
Hepta.
Remember, dichlorine heptoxide. Silicon, phosphorus, chlorine, they're all non-metals. Notice that silicon is right on the black line. For chemical purposes, chemical reactions, and for naming compounds, there is no such thing as metalloids. Okay, metalloids, or we worry about metalloids when discussing physical properties. Connectivity, is it shiny, not shiny, stuff like that. But for naming and chemical reactions, you're either metal, that fits out of the staircase, or non-metal, that fits out of the staircase. So silicon is a non-metal. Sulfur, metal or non-metal? Atomic number 16.
Non.
What's that, covalent or ionic? covalent. Ba is barium. Atomic number 56. Metal or non-metal? So it's an ionic or covalent? Ionic. Right. Covalent, ionic. So if it begins with a metal or NH4,
That
then
is
it's ionic. Copper, metal or non-metal?
Metal.
So that makes it ionic. Nitrogen, metal or non-metal? So that makes it covalent. So for all of them, name the metal or non-metal. So silicon. Okay, barium. What's the name for NH4? NH4 is called ammonia. And ignore the capitals. Now we name the second part. If it's a non-metal, it ends in IDP. Silicon oxide, barium chloride. If it's a group, you look it up on your handout. So after ammonium comes PO3, so you look up PO3 on your handout, and it's called a phosphite.
it's a group. Okay.
If you have a group, look it up on the handout. Oxygen becomes oxide. If it's a covalent compound, then we use prefixes to indicate the subscripts. So, no subscript, leave it alone. I have 3, so we add the prefix for tron. It's not covalent. Ionic, 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 covalent. Prefixes. Prefix for 2 is,
Di.
and for 4,
Hepta.
tetra,
Tetra. Sorry.
PA. Now for the ionic compounds. Okay. Do I need a Roman numeral?
No. Wait.
Because it's
No,
in
because
group,
2. It's in group 2.
Group 1, group 2, group 3, same cadmium and silver. You not need Roman numerals. So we're done. That's it. Barium chloride. Don't mess with it. Don't do anything else. Ammonium behaves like a group 1 metal.
Always? Just does?
So that's it. Copper. Don't need a Roman numeral.
Yes.
Yes. We have to calculate it. So you need to know what the charge on carbonate is. The charge on CO3. You look up CO3 on your handout, in the table of polyatomic ions, it should tell you that it is a -2. How many carbonates do we have in the formula? How many CO3s? Remember, there's no parentheses.
So 2 CO3s? Ah.
How many coppers?
2. And 3 CO3s. Ah, damn it.
How many CO3s? 1.
Then what are those numbers for?
That one?
Yes.
It's part of the CO3.
It's part of the group.
So that puzzle,
Oh.
as a group, this is here. We do not have parentheses. If we need it, if it's more than one, then it is going to be in parentheses.
Oh.
Okay. So, I have a total of -2. I need to cancel that with a +2. What is each copper so that I get a total of 2?
1, no?
So each copper is a +1.
Dang it.
Do not do -2 times 3. -6, cancel that with a +6. 6 divided by 2 is 3. And then you put carbon in 3. Excuse me, copper in 3. Also, this is not a Roman numeral. Do not do copper 2 carbonate either.
So why is it different for this one? Instead of like the multiplying and then dividing?
-2 times 1 is -2. Cancel that with a +2. 2 divided by 2 is that what you're counting?
Yeah.
I get it. I have to worry about it making sense.
Yeah.
Yes. Wax up the chloride phosphite copper 1. So on your handout, on this lab, do we have a lab too? Do we? Yeah, compounds in the Okay, now we haven't covered everything. So, okay, so part F, hold on for part F. So leave part F blank for now. I will cover part F during lecture. And then after I cover it, then we can work it. But I still need to. Well, don't turn, from today's class, don't turn anything in today.
Do you want the last lab in?
Last week's is.
Yeah, okay.
But from this, don't, not till next week.
So we can finish it.